Leetcode 424, longest repeating character replacement. It's a medium problem, but maybe a little bit on the easier side, because if you already understand the problem, the solution doesn't take that much to code. Yeah, so there are a lot of different problems classified as medium, and some of them are really compact, some require a lot of writing, and in this case, it's probably on the easier side. So the only hard part actually, or the medium part to be precise, is understanding exactly what do they want. So I will try to highlight what might be confusing and explain it to the best of my ability. So here is the description. You are given a string S, that's our first input, and second input an integer k. Yeah, so a number, integer k, and a string, so collection of characters or a word. You can also think about it in that way. You can choose any character of the string and change it to any other uppercase English character. Yeah, so we can replace any character with any other character, but there is a constraint on it. You can perform this operation at most k times. Yeah, so maximum we can replace any character k times. Yeah, so the thing that might be confusing is that you don't have to choose once you start replacing, you don't have to replace the same character. Yeah, so in the examples they are just having two characters A and B, but in the test, in all the test cases, there might be various characters next to each other, and you can change multiple different characters at the same time. The only constraint is that in total those characters shouldn't be more than k. Yeah, but you can change many different. And the task is to return the length of the longest substring containing the same letter you can get after performing the above operations. Yeah, so this is important. We just return the length, an integer. You can see it here. And we don't have to keep track of this final string itself. We just care about the number, yeah, the length of the longest substring. Yeah, but the substring itself, we can forget about it. We just need to keep track of the number. And here are the examples, which are quite simple. And first, you have 4 letters A, B, A, B, yeah, and k equals to 2. So the output is 4 because you can, of course, replace any two characters. Yeah, so you can, for example, replace both B's to A, and the whole string would be the longest substring, or you can replace in the other direction both A's to B's, and then you will have just B's, and again the whole string would be its longest substring with same characters. And the second example, you can replace only one character, so you have to find the longest chain or the longest substring of similar characters next to each other, or the identical characters. And in this case, it's either here A and A together or B and B. Yeah, so you can replace after those two A's B to A, and then you would have output A 4 times A. Or you can replace this A to B, and then you would have B, 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 and B. Yeah? And the output is again 4. And here there is some additional explanation. Replace the one A in the middle with B. Yeah, so this one form A, B, 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 A. Yeah, and this substring has the longest repeating letters, which is 4. There may exist other ways to achieve this answer too. And so we have already discussed it. There might be more than one option, yeah, but we don't have to care about it since we only return the length of the longest substring. Okay, so let's copy this and think about the way we can solve this problem. Let's also copy one example, for example, this. Yeah, and let's mention that every other letter is candidate for replacement. Replaced letters do not need to be identical. Now we just an important piece of information. We can make it a bit bigger, like this. And we'll try to make a dry run, or maybe not a dry run, but we'll try to first come up with an algorithm and then try to use it here within Xcali Draw on that example, without any code first, just thinking about how we can potentially solve it, and then we'll translate it to Python by the end of this video. So what kind of algorithms or what kind of strategies can we use here? The strategy that is very common for those kinds of problems is sliding window. And in sliding window, you will have 2 pointers or 2 indices. Yes, one somewhere on the left side and the other somewhere on the right side. And you will be either starting from the most from the longest possible substring, the longest possible range, like here, and then trying to make it smaller and smaller, and trying to check for some conditions while keeping track of some calculations. In general, I'm talking about sliding window, or the other way around. The other way to do it is to have at the beginning the smallest possible window and then try to expand it as we go. So we could have, for example, first just a single character, then take into consideration 2 characters, 3, and maybe if something happens, we will move the left and so on. To keep to check as many possible substrings as possible. And generally when we talk about substrings or subarrays or something like this, then the sliding window is the way to go. And we want to check, as I said, as many as possible, but not too many, because of course we could check every single possibility, but that wouldn't be optimal. So at some points you can see that, for example, you have in this case more than k different numbers to replace, so such window wouldn't be possible to wouldn't be possible to expand. You could expand it, but if, for example, we have such a window and we already see that there are 2 different characters and the maximum amount here is k equals to 1, then we can already see that if we try to expand it anymore, then for sure we won't find anything that will help us to solve this problem, because we would be getting more and more various letters and the maximum has been already exceeded. So in this case, because we have this constraint for the maximum, probably we should start from the smallest possible and try to expand it as much as possible up until we have no longer option to expand it, meaning we have exceeded the number k. So let's write it down and start with smallest possible window, both L equals to 0 and R equals to 0. Both pointers or both indices, we will start from the left. We could also start from the right, but it's more natural, I think, to start from the left and move to the right. And try to expand by incrementing R. So first they will both be on the same spots at the very beginning, then we'll increment R by 1 by 1 by 1 up until if the total number of other characters and maybe first let's mention what do we mean by other. So within the window from L up until R, count the most frequent. We care only about two things: the most frequent character and the total number of all others. And total of all others. And this one here. If the total number of other characters exceeds k, then what? Then increment L. Yeah. So if we find that the total number of other characters exceeds k, then we can move. For example, if we reach this place, then we can move L, and so on, and then we continue moving R up until again the total number of other characters exceeds k, and then we can move L again, or up until we reach the end of our string. Yeah. So either we have checked all the possibilities already, all the valid possibilities or theoretically valid possibilities, or we can move the left position or the left pointer and consider one more window. And while we do this, we have to keep track of, I can just copy this. Keep track of window length and store max in some variable. Yeah? And by the end, we need to return the length of the best window that we have considered within the string. So we have to keep track of this. And now we can think about some variables that can help us. And we can have count, some kind of dictionary that will keep track of the frequency of each character within the substring. So for example, if we take this window starting from B and ending at this A, then here the count for such window should return that B appears 3 times and A appears 2 times. Yeah, so each time we should try to update this count depending on how big is our window and where it exactly is. And the next two things are, of course, L and R. And the most frequent character so far. So that's more or less it. And now we could simply just go one by one and try to update them and then convert these lines of code to Python. So in the first iteration, we will have S on position 0, which is equal to A, and we will update the count to A equals to 1. Yeah. The window will be from not 1, but 0 till 0. Like this. and the total of others is 0, and there is only most frequent. Most frequent will be that I don't know yet. If we want to keep the most frequent as number or as letter, maybe let's have it as number. And because either way, all frequencies will be stored here in the count dictionary, so we can just store here the count, which will be the same as here. Yeah, but just to retrieve it quickly, we can have a separate variable for it. And most frequent will be 1 in this case, and the total number of other characters doesn't exceed k, so we can simply proceed to the next iteration. Yeah? And in the next iteration, we have still a. This one will be updated. Let's make it bigger. Like this. And this we can move to the right, separate to make it a little bit more readable. Yeah? So let's update the R and have like this. And now the new window is from 0 to 1. So that's the new window. And the total number of other is still 0. The most frequent appears 2 times. Then in the next iteration, let's copy this here. The next character is B, and I forgot to update it here. Yeah, so let's update like this. The B will be we have the first B at this point, and we have to set it to 1. Yeah, so R gets updated again. Got this, and the window is from 0 to 2. Total of others is 1. Yeah, but still 1 is within this range, and the most frequent is equal to 2. Yeah. And then the next would be A again. So we update it here. We update it here as well. We update it here. And we update here. Total others is still 1, and the most frequent appears 3 times. Yeah, and that's it. We move it to here. Zero to 4. Then B appears 2 times. And we have to update here. Now it's equal to 4. And I can remove most frequent from here since we are updating it 1 by 1. Total others is equal to 2, which exceeds our limit. Yeah. So here was the limit. And this one, unfortunately, exceeds the limit. The limit. So the previous valid window was from 0 to 4, meaning length 4. No, sorry, the previous values window, this one is from 0 to 4, the previous was from 0 to 3. Yeah, because right now we have exceeded the limit, so we know that we already have a window which is too big, and now we have to check. The previous values window has length of 4, and this is something that we can store in some result. Yeah, and continue this process up until either we find we reach the end, or up until we reach the end. There's no other option. So we will be updating, but at this time, the first time when we exceeded the limit, we update some result variable if it's the best found so far, and finally we update also what left. So this would be the first time we do it like this, and the next value for left would be 1. And that's it. We would continue with some more iteration, but I think that you get the point. Now it's the time to try to use the same thing in Python. So count can be a default dict of integers. Default dict is better for this problem than normal dict, because in default dict you will have, when you set it to int, to the type int, you will have default values for the keys that are not already there. Yeah, so you can always check, for example, what is the value of b even before we added b to this dictionary. And simply, when it's not added yet, that means that it will return 0 for that particular key. We can also initialize L and R. Sorry for that. And now we can, by the way, R can be here inside the loop. For R in range len s, or simply for R / current character in enumerate s. And we can increase the count of current character plus 1. And now we have to find the most frequent we will have to find the total number of other characters. Let's write it down first, and then I will fill the blanks just to get the skeleton, and then we'll go back to it. And if total others exceeds k, that means that we have to update L. We can also have some final results towards, and we also have to update count. Not for current character, but for S on position L before the update. Have to decrease it, since we moved the window, and here we can update the result. Would be max between the previous result and L plus R minus 1, or just total others. This could be total, and we can use it here. Okay, and by the end we return the result. So now two things left, how to calculate most frequent and the total number of other characters. Most frequent, we can also initialize it here to 0 and simply check if the one that we incremented is bigger than the previous most frequent. And most frequent. Yeah, and the total number of others is most frequent minus the total minus most frequent. That's it. Let's try. Wrong answer. Output 2 should be 4. Let's see. And yeah, of course, that's wrong. R minus L plus 1. Yeah. Don't know how I get this previous version and was not thinking straight. That's because we don't update here. Yes, since once we increment this, then it also influences this part. So let's see. Okay, let's accept that. So let's try to submit. Bit 84%, and I wonder if we get rid of those variables. So the total is this. Oh, we can just get rid of it and put it here. And the total others is this. If I didn't make any mistake. Let's see. Yeah, and it's a bit faster. And so if you don't use excessive variables, it might be a bit faster, but of course the code becomes less readable.